I'm Dr. Darren Chitty, and I'm going to present my poster summary using Partial-ACO as a GA mutation operator applied to solving travelling salesman problem instances. We know that travelling salesman problem is a difficult combinatorial problem, especially as problems get larger, and there are two primary meta-heuristic methods used for this approach. Genetic algorithms, which use the principles Darwinian evolution and crossover mutation to generate new solutions, to successfully improve solutions towards optimal solutions, and Ant Colony Optimisation, which uses the behaviours of ants to guide choices at each step of the solution using pheromone. Pheromone deposits on edges between cities guides ants to making better solutions, and the amount of pheromone they deposit as they traverse a solution is dependent on the quality of the solution they have. But both these approaches have disadvantages. GAs require computationally costly local search methods in order to have any success at large problems, whereas ACO has a high memory overhead through a pheromone matrix, and also simulating ants making lots and lots and lots of decisions is computationally costly, and also with that level of decision making can be quite error prone. However, is it possible to combine both these methods to mitigate their respective disadvantages? A new novel version of ACO called Partial-ACO could be used to achieve this. It dispenses with a pheromone matrix, and so it builds pheromone levels from the current ant population on edges, so ants can use those when making decisions. And in addition, they only partially modify their locally best found solutions. So they do this by copying a section, a random amount to retain, and then they build the rest as you would normally find in ACO. But this could be considered similar to mutation in a GA in that only part of the solution is being changed. And the advantages to this Partial-ACO approach is there's no pheromone matrix, so no memory overhead, and quadratically reduced computational costs. And also, in addition to that, it has proven to be generally more accurate because it reduces the amount of errors an ant may make through less decision making, less gambling essentially. As I say, it's been found to be faster than ACO and more accurate than ACO. So we can embed this into a GA using basically the GA population to generate the pheromone levels. You can just use it rather than ant, just as easy as an ant population. And when mutation is required, a random section of solutions can be nullified, leaving a partial solution to be rebuilt. As we can see on the right with the red X's, that's the bit that's been nullified, and the unvisited cities are on the far right, 4, 5, 6, and 7. And so we position an ant at city 3. It's then got to make a choice from 4, 5, 6, or 7. It chooses 6, which you can see on the green there, and then the ant moves to that city and then repeats the process. And this repeats until it builds a complete solution. And as I say, it can use pheromone from the entire population of GA solutions rather than just a couple of them which crossover would use, and it can use heuristic information. So we tested it on a range of TSP instances from the TSP library, and we used a baseline without using Partial-ACO, so just using swap inversion, insertion, mutation, and then we added Partial-ACO as a fourth available mutation, and they're uniformly randomly selected in the process. And we use CXOX and PX crossover, and population 128 evolved for 100,000 iterations with a 1 in 3 probability of mutation. It's important to stress there's no local search methods used. We're only interested in the pure evolution results. And we can see from the results here, in terms of the relative error, that the Partial-ACO mutation in a GA generates far higher quality solutions than using just the standard mutation operators here. The results of GA are quite poor, getting up to almost a 50% error, whereas certainly with the CX crossover, the Partial-ACO mutation is within a few percent of the optimal solution. And the reason this is that Partial-ACO mutation uses problem domain knowledge, the heuristic information there, plus pheromone from the whole population rather than just looking at a couple of individuals, whereas standard mutation operators are random in nature. So, in conclusion, ACO can be combined quite easily with a GA, as long as it's Partial-ACO, and the results are considerably improved over using other standard mutation operators, getting close to optimal solutions up to 4,000 cities, and without using any local search. Future work will consider adding this local search and seeing whether we still get a benefit from that, and also looking at perhaps multi-point mutation where we select more than one section to be nullified, as it were. And we'll also look at using ACO as a crossover operator, just as much like CX or X. So thank you for listening.